So the first half of this unit, we were looking at angle rotations and reference angles and things of that nature. The second half of this unit, we're going to kind of go back to some what you would probably call traditional trigonometry, where we're working with some triangles. So the first thing we want to do is we actually want to review how to solve right triangles, how to find angles, etc. using SOHCAHTOA. So we're going to do a few quick examples. In this question, they want us to find angle x, and we know the opposite side and we know the hypotenuse. So opposite and hypotenuse in this case is sine. So we know the sine of x degrees is the opposite, which is 8, over the adjacent, which is 14. So we take inverse sine of 8 over 14 to get our angle in degrees. So make sure your calculator's in degrees, please. You have no hope of finding the angle in degrees unless your calculator's in degrees. So we go inverse sine of 8 over 14, and to the nearest whole degree, this angle x is 35 degrees. So that's pretty straightforward. In this question, they tell us the angle. We don't know the hypotenuse, but we know the adjacent side. So adjacent and hypotenuse is cosine. So the cosine of 40 equals 19 over x. So to solve for x, we have to take 19 divided by the cos of 40. We just switch the position of these. So get out our calculator and go 19 divided by the cosine of 40. And we get 24.8 units, but it says it wants us to round to the nearest whole number. So that makes this 25 units. In the second set of example here, they want us to actually find the length of BC, this whole side here. So we're going to have to find this side that I'm labeling X and that side that I'm labeling Y. We're going to have to make two calculations. So in this left-hand triangle, we're looking for the opposite side, and we know the hypotenuse. So opposite and hypotenuse is sine. So X is going to be the sine of 20 times 12.5, and if you get out your calculator and you calculate that, you're going to get sine of 20 times 12.5. It's going to give me 4.27, or if I round it to 2 decimal places like it asks me to, that's 4.28. If I look at this side here, I don't know any of the sides in this right-hand triangle, so I've got to find this middle side, AD, so I can use it to help me find Y. So AD is the adjacent side, and we know the hypotenuse. So the cosine of 20 is the, I'm going to call this side Z, is Z over 12.5. So Z is going to be the cosine of 20 times 12.5. So the cosine of 20 times 12.5 gives us 11.75. So this side is 11.75. Now we're looking for the opposite side, and we know the adjacent side, so that's tangent. So we've got the tan of 55 is the opposite side over the adjacent side. So Y is going to be the tan of 55 times 11.75. So the tan of 55 times 11.75 gives us 16.78. So we know this side is 16.78. We know this side is 4.28. So to get BC, we have to take 4.28 plus 16.78, and we get 21.06. And it's centimeters in this question because the units in this question are centimeters. So that's a quick review of some right triangle trigonometry, similar to what we did in Math 10C. So now we're going to talk about non-right triangles. How do we find angles? How do we find sides in non-right triangles? And what we're going to do is we're going to look at something called the Sine Law. And we're going to look at a triangle that I've created, and I've taken some measurements on this triangle. And we're actually going to put these measurements in a table, and we're going to see what we discover. First of all, they tell us side BC is 19.66, side AC is 10.44, and side AB is 14.33. Now angle BAC, the middle letter tells us the angle we have is 103.97. ABC is 31.02 degrees, and ACB is going to be 45.01 degrees. So we filled in all this information in our triangle. It's a non-right triangle. There are no right angles in it. So now what we're going to do is we're going to translate this information to this particular table. But there's a couple things you need to know before we do that. First of all, angles are always labeled with capital letters. Sides are always labeled with lowercase letters. So across from angle A is side A, across from angle B is side B, and across from angle C is side C. So when we put A, B, and C into our list, we're doing sides A, B, and C. Angle A is 103.97, angle B is 31.02, and angle C is 45.01. So now what we're going to do is we're actually going to calculate this ratio. We're going to take side A divided by the sine of angle A. So we're going to take 19.66 and divide it by the sine of 103.97. If we do that on our calculator, let's get it up here where we can see it. We're going to take 19.66 and divide it by the sine of 103.97. I get 20.26. We take B, which is 10.44, and divide it by the sine of B, which is 31.02. Well, 10.44 divided by the sine of 31.02 gives us 20.26. And if we take C, which is 14.33, and divide it by the sine of side C, angle C is 45.01, 14.33 divided by the sine of 45.01, we get 20.26. So what we notice about a non-right triangle is that these ratios are all equal. We have discovered the sine law, and that law is on the second page of your workbook. If I was you, I would find where the sine law is, and I would highlight it. It's one of those formulas you need to be able to use. You do not have to memorize it. We're going to give you that formula, but you need to know how to use it. What you need to realize is the lowercase letters are sides and the uppercase letters are angles. So now we're going to take the sine law and we're going to use it to help us find angles and sides. However, before you can use the sine law, you need to know three pieces of information. You must know the numerator and denominator of one of the three fractions. So basically what they're saying is you need to know a complete fraction, either A over sine A, B over sine B, or C over sine C. You need a complete one of these to be able to use sine law. And you need one other piece of information, either a side or an angle, in one of the other fractions. When we use sine law, we don't use all three fractions at the same time. We only use two of them to solve a question. And you'll see what I mean in a second. If we look at this example, in this case, we know angle C and we know side C. So we know this. What are we looking for? We're looking for angle A. So the other ratio we're going to have to use is A over sine A. So the ratio we know completely, C over sine C, is one of the ratios we need to use. Whatever we're looking for is going to tell us the second ratio that we need to use. So if we now start substituting information in, we get 12.50 over the sine of 35 equals x over the sine of 75. Now, the biggest mistake people make when they solve sine law questions is they put the information in the wrong position. Remember, side C is across from angle C. Make sure you put angle C in the right position. Angle A goes in this position, and we're looking for side A. So what do? We cross multiply. We get 12.5 times the sine of 75 equals x times the sine of 35. So to solve for x, we have to move sine 35 to the other side. We have to divide it. So we get 12.5 times the sine of 75 divided by the sine of 35 is going to give us the value of our side. So if we take our calculator, we're going to go 12.5 times the sine of 75. Make sure you close the brackets. Hit enter. Then we're going to divide that by the sine of 35, and we get this side to 2 decimal places to be 21.05. Now, if we look at this again, this is centimeters. So that's not too hard. Let's look at another question. In this question, we know angle A and we know side A. So we're going to use A over sine A. We know side B, and they want us to find angle ACB. That's what they want us to find. They want us to find this angle here. Well, we don't know the side across from this angle, but if we find angle B, we know all the angles in a triangle add to 180 degrees, so that will help us find angle C. So we're actually going to use B over sine B to help us. Side A is 9.4, angle A is 110, side B is 6, and we're looking for angle B. So we're going to cross multiply. We're going to get 6 times the sine of 110 equals 9.4 times the sine of B. So now we're going to divide by 9.4. We're going to get 6 times the sine of 110 divided by 9.4 equals the sine of B. So if we calculate this, we go 6 times the sine of 110, close the brackets, hit enter, divide by 9.4, we get this big long decimal. Now, we need to use the whole decimal to calculate our answer, but when we write that down in our work, we're only going to write down 4 decimal places. Now, how do I get the measure of angle B? Well, I have to move sine to the other side. I have to take inverse sine of 0.5998. So on my calculator, I'm going to go second function sine, and I'm going to go second function answer. Answer is down here on this negative key with the brackets on it. So what that does is actually takes the last answer and puts it into this position. And to the nearest whole degree, that's going to give us 37 degrees. Now, you're watching me do this on the video. Hopefully you're also trying to do it on your calculator so that you can actually see, can you do these calculations? If you haven't tried doing this on your calculator, quickly whip out your calculator and see if you can do these things. Now to find angle C is going to be 180 minus 110 minus 37, which gives us 33 degrees, because all 3 of these angles add to 180 degrees. Now, last example we're going to do gives us some measures, just tells it to us in a problem, and asks us to calculate the perimeter of this triangle. Well, perimeter, remember, means you have to find the length of all the sides in this particular triangle. So we're going to take the information they give us. They tell us PQ is 440 meters. Tells us that angle P is 46 degrees and angle Q is 75 degrees. So we can figure out angle R to start with, and that would be a good thing because we need to know angle R because we have side R, so we're going to have to use that to help us calculate our solution. So angle R is going to be 180 degrees minus 46 minus 75, which gives us 59 degrees. So now, lots of you are going to look at this triangle and you're going to go, hey, like, we don't have A, B, and C. So what I suggest you do to help make the formula easier is go and change these from P, Q, and R to A, B, and C. That's going to make our life simple. We know side A and angle A. We're going to look for side B and we're going to look for side C. So we're going to have to do two calculations. So we're going to do B over sine B and we're going to do C over sine C. So if we start with the first one, side A is 440, angle A is 59, side B is what we're looking for, and angle B is 46 degrees. Don't forget, this is angle B and that's side B. So if we cross multiply, we end up getting 440 times the sine of 46 divided by the sine of 59. And if we take out our calculator and figure that out, 440 times the sine of 46 divided by the sine of 59 tells us that side B is 369.25, in this case, meters. If we do the same thing here, we get 440 over the sine of 59 equals C over the sine of 75, because angle C is 75 degrees. So when we cross multiply, we get 440 times the sine of 75 over the sine of 59. So when we calculate that on our calculator, 440 times the sine of 75 divided by the sine of 59 is going to give us 495.83 meters. So to find the perimeter, we actually have to add all our sides together. So we have to take 369.25 plus 495.83 plus 440, and what ends up happening is we end up getting to the nearest meter, is what it asks us, is 1,305 meters. So that's not really too bad. We had to do a couple side calculations and then add it together, but that was fairly straightforward. Sine law isn't that difficult, so hopefully you find the assignment fairly easy.